Hello everyone, welcome to the lecture for week 6. This week we're going to look at a range of different things. It's listed on the course outline as Intro to Texture Baking. We've actually done a bit of texture baking already, both in the initial intro and throughout a couple of the different steps. So while we will cover that today, we will also cover a range of things that go with it. So as a recap of the asset creation pipeline, or at least the asset creation pipeline that we're looking at in this course, step 1 is to generate the high-res model or the subdivision surface model. This high-res model we looked at briefly last week. I'll recap some of that stuff today. Then, once you've got your high-res model, whether that's generated through sculpture or subdivision modeling or photogrammetry, which we're about to have a look at here, that high-res model, you then make a low-res model to match it, and then you will take the details from the high-res mesh and bake them through textures, whether that's the ambient occlusion, the normals, roughness, metallic. You will bake those maps from the high-res mesh to the low-res mesh, and then the low-res mesh and these textures then go into Unreal, and then the material is created in Unreal, the textures are plugged in where they need to go, and that is your in-game asset. So high-res, then low-res, then texture baking, then materials in Unreal. There are a range of different ways to create the high-res mesh. Last week we looked at the subdivision surface modeling. That is still arguably the main way to create most models, especially created objects. So anything that's been machined or put together by people. Organic objects, whether it's trees or characters or anything sort of with natural curved flowing forms. Pretty common these days to do that in ZBrush or a sculpture program, but again, subdivision surface modeling works for both the organic and hard surface models. The other way to start to generate your high-res meshes is through photogrammetry or laser scanning. Both of these are options within Adelaide. There are companies that will help you with both. This particular example is photogrammetry. So while laser scanning is exactly what it seems like, you have a handheld scanner and you run it over the surface of the object, and based on the depth of where the object is and the amount of feedback that it gets via the laser back into the scanner, photogrammetry works by taking a whole range of photos from slightly different angles. The computer will then match points in all the different photos, reverse engineer what angles the cameras are at, and from there it can create the points in 3D space. These points are then processed into a mesh, and a texture can be applied to that mesh from the cameras, and you get what is a very, very nice starting point for creating your models, whether they be the low-res in-game mesh or whether you use this as a reference point for creating a subdivision surface model for your high-res mesh. I have recorded a separate video that covers the photogrammetry process. You won't need to know how to do this for the course, but it is becoming more and more common in games, so I thought I would cover it slightly for those who want to look into it. Blender can obviously bring in the resulting mesh. Blender doesn't really have photogrammetry tools in it, so you will need a separate piece of software to actually do that. A range of them have 30-day trials and things, so the one that I've used in particular I have a license for. It is Agisoft Metashape. It used to be Agisoft Photoscan, but they updated it and changed the name. So with that one piece of software and one decent SLR camera, for reference, it's a Canon 550D, so not a crazy expensive camera, but a reasonable SLR. using that one camera and that piece of software, I was able to generate this mesh. And if you follow the video on the side, you will see the sort of the basics of that process. However, now that we've got that mesh and the texture that goes with it, we can use that as a reference for creating our model. So the next step we're going to look at is called retopology. So this is a pretty common thing within games, film, any sort of animation, to go from an existing high-res mesh to then make a matching low-res mesh to go with it. It is possible, of course, to do the low-res mesh first and then work your high-res mesh from that and sort of add details progressively. Broadly speaking, I think it's still more common to make the high-res mesh first. So you get absolutely all the details that you want, get it to the size, scale, etc., and then generate the low-res mesh to match. That's usually the process I do. Depends a little on the project, but that is what we're going to look at here. So retopology kind of is exactly what it sounds. It's taking an object and creating another object with a new topology to it. We've brought in our high-res mesh. I have scaled it how I want it because I scanned in the calipers on top of the dashboard and put in a red cube. This red cube is then scaled down to be 1 centimeter by a millimeter by a millimeter. It's very faint on the texture, but I've aligned the mesh to sort of match that in scale. We don't need that anymore. So what we're going to do from here is create a new mesh. So Shift A, add mesh plane. Again, this can also be done through the add menu up the top here. This plane is obviously sort of too large, so tab into edit mode, delete those spaces, we don't need them. Naming conventions, we will do this as car dash low res. So at the moment this object is empty. If I was to just turn snapping off for the moment, control right click will get us our new vertice, E for extrude, shift select, E to extrude a face. This will just create a face or a set of verts in the middle of the scene, in the middle of space. Often if you're working in perspective, it'll just sort of shoot it wherever. What we're going to do here is take a look at the snapping tools. Hopefully you've been using these a little bit in terms of the increment snapping. So increment being the default one there. If I was to turn snapping off, G for grab will just move it wherever. If I hit control and move, this will snap it to a grid point. What we're going to want to do here is change this snapping mode to face and make sure, I believe it's off by default, project individual elements is turned on. So snapping tools, face, project onto self, and project individual elements all sort of turned on. Project to self we don't really need, but leave it on for now. And then if we click this icon here, so the magnet icon for snapping, this will mean that by default snapping is on and will snap to anything. If I then hold control, it'll turn snapping off. So it basically inverts that, so snapping is the default thing that we have on. This is what we want. So now, if we were to select all of these verts, B for border select, and then selecting all of those, G for grab, what this will do, especially with snapping turned on by default, is anytime you move a vertice on this new mesh that we've made, it will snap it to the surface of the high-res mesh underneath it. So the general idea here is now we can effectively trace one shape onto another. This is very, very handy and a very, very efficient way of working. The reason I didn't really cover this earlier is, for starters, it's good to get a hold on the general sort of modeling tool. your basic extrudes, bevels, bridging faces, all that knowledge still comes into play here. It's just that we get a very efficient, very sort of accurate reference point for tracing our mesh. So X to remove an edge loop. So what we can do here is, like I said, just trace one shape onto another. So whether this is the starting point for your high-res mesh to then go back in and add in a bunch of extra edge loops and the subdivision modifier and get that going, or whether this is going straight to the low-res mesh is up to you. But yes, you can then fairly quickly, again, depending on the shape and how accurate the scan is, just draw one mesh over the top of another. I won't spend a huge amount more time using this photogrammetry example, but we'll cover a few more things and then go to a model that's done much more in the way of the subdivision surface that we looked at last week, and retopologize one of those. And that will be the practical this week, is retopologizing a mesh, a high-res mesh that has been modeled using subdivision surfaces and generating the low-res mesh from it. It's a good example, though, to use this photogrammetry, because, like I said, if you end up doing this in sort of a production environment or a larger sort of game, photogrammetry is becoming more and more common. So I just thought I would use this to start this week, and as an example to get things going. So something that you will notice on the faces, particularly the ones I'm doing here, is the faces of our new mesh and the faces of the existing mesh are sort of flickering between each other. That is because if I was to turn the texture off, so we go back to our solid view, so again, the viewport preview will bring the texture back, but if we check this second one along, you'll see that the photogrammetry tends to come out fairly lumpy. So again, the higher the quality of the laser scan or the photogrammetry, the smoother the resulting surface will be. So along the front of the little glove box here, that has turned out quite flat and quite accurate. The further we go into shadow, there wasn't nearly as much detail in the photo because there wasn't enough lighting down there. It gets lumpier and lumpier and then sort of goes away. Same with the door. I wasn't actually trying to capture the door. It's just because I was working on the dash and the photos could see the door in the background, it's extended the photogrammetry out that way. This is very common for photogrammetry and scans as a starting point. So while they are very, very handy for getting the proportions of everything right, and there's a certain accuracy that comes from that. So, I mean, you wouldn't put a Hyundai Getz in a racing game, but if you were trying to accurately recreate existing objects, this can be very, very handy. However, once we've made our low-res model, we just sort of continue this around. Obviously, I wouldn't want the actual calipers in there, so what we can do here is E to extrude. These verts are either side of the calipers, so it's going to ignore them and stay at a certain height there. We can select these, create a face. Same again, extrude out, select these, create a face. If we were to bake the normals of the photogrammetry scan from this high-res scanned mesh to the low-res mesh that we're working on now, the normals would look like this. So there would be all that lumpiness and we probably wouldn't want it. However, just as a quick example, if we were to bake the color information into the diffuse texture, that might actually provide a good starting point for your textured mesh. So let's just, for example, say this is all we wanted out of this dash. We're going to bake the textures from that. We will still need to go to our UV editing Again, screencast keys. So we've got our low-res mesh, we've got our high-res mesh, UV, unwrap, being a relatively flat, relatively low-res example, that'll do for now. So if we were to bake just the color information from the high-res to the low-res, we would need to go to materials, add a new material, and again, this is just so Blender has an image that it knows to bake to. Under here, we can do what we did for the texturing sort of process on assignment 1 and week 4. Just change that to a diffuse BSDF, remove all those other options because we're not going to use them. So object mode into edit mode on our low-res mesh. We've got our UV done. Image new, this is going to be the new image we're going to bake to, so this would be car dash diffuse. Click OK. Now, this high-res mesh has a material on it, dash photogrammetry. The image texture is applied to it, but if we needed to create a new material for that, just for the example, we would do new, make that high-res dash, change to diffuse, add image texture. So if we look at our high-res dash texture, and we can choose that here, this is what a color map looks like within the photogrammetry software. So it's just diced up as many different sections of that mesh as it can, assign textures to it. This whole thing is 8K, so roughly 8,000 pixels by 8,000 pixels. I think it's 8,192 to be specific. This is unusable for a game, not to mention that the mesh is unusable for a game because of the sheer poly count, all the lumpiness. However, we can take color from this map and bake it onto our new map, which we're going to do. Take the high-res one, select that in object mode, shift select our low-res mesh so that it becomes the brighter orange. It's the most recently selected. This may be clearer in wireframe slightly. As you can see, the wireframe on our photogrammetry mesh is quite dense and triangles everywhere. But as long as you've got the high-res mesh selected first, the low-res mesh selected second, so it's the active object, brighter orange. Tab into edit mode. That's not what we want. Again, a old Blender, new Blender thing. Previously in Blender, whatever the most recent active object was, that would be the only one you enter into edit mode at any one time. The new version of Blender, you can enter edit mode on 2 different meshes or more at the same time. So again, we'll just make sure we're baking to the right texture. So low-res mesh, select that, remove the link to that one. Car dash diffuse is active in the UV editor. And then on color here, add image texture, car dash diffuse. So just to recap those last few stages, if we go back into object mode, we have a low res material, we have our high res material. The image texture on the high res is the dash photogrammetry. The image texture on our low res is the low res dash even. Is our new car dash diffuse. Take the high res, shift select the low res, that is active. Go back to our render properties and expand out the baking tab, which is in cycles instead of EV. EV is the sort of more the preview renderer. It still has some ray tracing to it, but Eevee is sort of the approximation and or preview, and Cycles is the full-on ray tracing. Use this for Pixar-style images. Eevee is handy and it has its uses. Cycles is much more fleshed out in general, and that is where our baking tools are. You won't really need to do any Cycles rendering in this course other than the baking, so we can ignore most of its settings. But if we just switch that from Render Engine Eevee to Render Engine Cycles, it will default to CPU. GPU will bake a whole lot faster, so just select that there. Now we can open our bake settings, and at the moment we want selected to active, which we covered briefly in a previous video, but I'll go through it again. With this selected, it'll take any other objects in the scene, take the textures or normals or whatever from those objects, and bake them onto the low-res mesh. This is what we want in this particular use case. However, all we really want is the diffuse at this point. You can bake a whole range of stuff, and we'll get to those later on in this video, but for now, if that's just diffuse, selected to active is turned on. These sampling settings here, the higher you set these, the longer the render will take, but the more accurate it is. For the baking, the defaults should be fine. So if we just click bake now, there is a progress bar at the bottom. It gave me a warning about circular dependency, so I think I've got these textures set up right, but if not, we'll go back and fix that. For reference, I've got a GTX 960 on 970 even on this machine. Newer graphics cards will bake faster, and typically the NVIDIA ones will go faster in Blender than the AMD alternatives. So now we've got our texture bake, and we can see if we hide our high-res mesh, go to our preview here, there are a couple of things going on. Firstly, we can see that there are black parts on the texture, or alpha'd parts here. What happened is the difference between the two meshes was too much. So Blender checked the difference between the two meshes up to a certain distance, and then just ignored anything further in terms of detail. This has left gaps in our texture, so we will need to go back and fix that. Secondly, the UV map was facing the wrong direction. So we can see from the text on the calipers, which we're going to paint out anyway, this texture is mirrored from what it needs to be. That one's an easy one to fix. It's one to fix within the UV settings. Thirdly, and this one will take a little bit more explaining, the texture is about half the brightness that it should be. So whilst it would be, a pleasant example to just unwrap something and everything works perfectly the first time, there is a fair bit of this that goes on in baking in general, and this is more of what this lecture is meant to be about, is the texture baking settings when they work, and how to tweak things and fix things when it needs a bit of further refinement. Because there will be a number of cases where things don't work the first time, but with a bit of nudging around, you will get very nice clean bakes out of them. So firstly, we will fix the UV map. So if we select everything over here, S for scale, X for the X-axis, if we do -1, that will flip it. So now our texture will look wrong in the viewport, but when we bake it a second time, just scale it in a little bit, that will be going the direction that we want it to. So secondly, the missing gap between the two, we will need to unhide our high-res mesh, shift select those two. This can be tweaked here with this ray distance setting. So with the ray distance, it's currently set to 0, so that will just do the defaults of, a best guess where it's sort of going to find things. If we bump this up to more like 0.1 of a meter, that might be a little large, but it'll force Blender to, when it's doing the ray tracing of putting the textures from one object onto another, it will force Blender to look a bit harder and go out further, so that sections like this, where the mesh is not as, like there's a bit more gap between the two, it will fix that problem. This can be a bit of a trial and error setting, but 0.1 should be plenty for what we need here. Now, the third issue, the brightness. So what's technically going on here, and again, this is something that used to work different in previous versions of Blender, in the same way that setting up a texture to show in the viewport is a little bit more time than what it used to be. Similarly, there's a little bit more going on that you need to check with a bake than there used to be in Blender. But the new way of doing things is more flexible overall. It just comes with a bit more setup time to go with it. So when we have baked our diffuse, instead of baking just the color texture from one to another, what we're actually doing is, if this was rendered in the viewport using cycles, which we can do with our fourth tab, and we won't use this particularly often. This may take a little while to set up. So that is where we're getting our darkness there. That is because the image texture is changing the color of the object, but there is also scene lighting, which is affecting how bright that object is. So what we're going to want to do here is change how bright the scene is, so that our diffuse pass, which is the color of the texture, multiplied by how bright the scene is, to get both. So we'll get the texture with the colors that we want, and we'll also get the lighting with the brightness that we want. This is easy enough to see in the viewport, fortunately, because of the preview settings. Again, how fast your graphics card is will affect how well this updates in real time. This is a very high-res example, but for most objects that we'll be doing in this course, it's generally okay to be able to move the mouse around and have a look at what's going on in real time. If we go to our scene properties, next one down, world properties. So again, things have been split a little different how they used to be. Within the world settings, we have our surface and a color. All we really need to know here is that background is currently how much ambient light is in the scene. So at the moment, the ambient light is coming through at a bit of a dark gray. If we were to change this value to 1, and then we look at our scene, everything in the scene is sort of being uniformly lit at a value of 1, which will give us our texture pretty much at the brightness that we want it. So that's all we really need to do. So it takes a little bit of explaining as to what's going on, but the short version is go to the world properties, change this color, value of 1, and it will now bake how we expect it to. So if we just go back to our solid view for now, save the scene, go to our render settings to do the bake again. Something else to cover with the baking is this margin setting here. So if we zoom in on the texture just before we bake our new one, we'll see on the sides that when it hits, we'll just select our low res mesh, when it hits the edge of the UV layout, we'll just mirror this back to how it was to explain it. So here's the old bake. When we get to the edge of this UV layout, it has given us 16 pixels outwards of the texture. So this is very handy, and I've mentioned it a couple of times, but when you bring your textures and objects into Unreal, there's a process called mip mapping, what that does is you'll have your high-res texture, whether that's 1024 by 1024 pixels, or often much higher than that. As your object gets further and further away from the camera, what Unreal will do is it'll swap that to a half-size texture, so 512 pixels, and then it'll swap it to a lower res texture further again. So whether it's 256 pixels or gets down to 64 by 64 pixels for the entire texture map. This is to save on texture memory, and often referred to as the level of detail pass, because the mesh will sometimes get a lower res mesh swapped as meshes get further and further away from the camera. If you've played any sort of open world game in particular, like a Skyrim or any of those, you'll commonly see, particularly in older games, as they got used to this process, as you get closer and closer to an object, you'll see the higher res assets swapping in as we go. What this has to do with this margin setting here is, as the texture gets scaled down and down and down in the different resolutions, these borders have a risk of becoming more and more visible and showing up incorrectly on the mesh. So if we give a little bit of space between our UV layout and have this border, which is set by the margin settings, 16 pixels is fine. You can crank that up to a maximum of 64. We'll just leave it as 16 for now. This will help when it generates the bitmaps, so that you don't notice the popping between the different resolutions. So again, long-winded explanation. All you really need to do is make sure you've got enough of a margin set, and that's what you need to do from a technical point of view. But the explanation does help as to that's what's going on in the game engine, and you do need to keep an eye on it. So scale x -1. This gives us back to the direction that we wanted it in. Snapping does work in the UV layout as well. For now, I just want to nudge it slightly to the side. But yes, you've got the different snapping options in here. For UVs, it's only snapping to increment or vertex, as opposed to the 3D view, which can snap to all these other options that make more sense from a 3D point of view. Just leave that off for now. Save our scene. Baking, so we've got our margin, we've got it set to diffuse, we've got the world setting is the correct brightness for the color. We can now hit, one more, shift select the high res mesh and the low res mesh second. Now we do bake. Again, we'll get our little texture bar down, progress bar down the bottom. Getting there, getting there. As a side note, photogrammetry does take quite a while to process. This particular example probably took at least 10-12 hours in total to do all the processing. You obviously don't have to be there for that. You just sort of set it going and then go out for a walk or a vacation, depending on how detailed the bake is. So this is much closer to what we want. We'll just hide that there. Go into our textured preview. So this is pretty much exactly what we want. There's still a few gaps, but the texture is the correct direction. It is the correct brightness. It has margins baked into it. So we can then use this as the starting point for our color texture on a much, much lower poly mesh. Clearly there's some black gaps still where the texture hasn't baked across. We could just continue to nudge that ray distance. For the purposes of this video though, what we're going to do is a bit of quick editing on the texture on the side. This can be done in either Photoshop or Blender. So if we were to go to our texture paint window, that's obviously the larger photogrammetry texture that we had before. If we go back to car-diffuse, and that has still got our high-res mesh selected for some reason. So we'll unhide that. Go from texture paint to object mode. Because we had both selected for baking. So if we hide that, select just our low res, go back, texture paint, we can start to make some adjustments. After a bit of experimenting just then, something I really need to flag is there might be a few reasons why texture painting appears to not work. For this particular mesh, the normals are actually inverted. So Blender will show you both sides of the mesh by default. Both will be textured, but you can only paint by default on the side that the normals are pointing out of. This is because backface culling, which is hidden nicely if you scroll down, options, expand out. We've got our bleed setting, which is how far it'll paint over the edge, so into our margin. Occlude, which is whether you'll paint on just the one mesh or if another mesh is in front of it, and backface culling is turned on. So I just found that rather frustrating. I don't believe this is how Blender used to work, but yes, by default, Blender will show you both sides of the mesh to paint on, but only one side will actually work with the brushes. So if we were to try and paint, that won't work. If we turn backface culling off, there we go. So again, you can paint in the 3D viewport, or you can paint in the 2D viewport, and it'll update once you let go of the mouse. This can be done in, so we've got our viewport shading, texture turned on, or as we were sort of doing before, in the look dev or material preview shading mode, the third one across. That will work as well. So again, it's one of those things that used to work just fine, and I was very familiar with the settings, but the defaults seem to be giving me a few issues with the newer versions. Anyway, moving along. If we were to take this clone tool, what we can do is control left click on part of the mesh to select this part of the texture, and just paint to fix these parts. So there is a clone brush within Photoshop. There is also a heal brush within Photoshop. Both are good for what we need. But yeah, just going to do a little bit of cleanup within the 3D viewport because it's easier to see which parts of the texture you're fixing up, whereas in Photoshop you might have to sort of go in and match up UV seams and all that sort of thing. So again, the margin setting for the baking has baked that all the way out to 16 pixels. By default, the bleed for this brush has only gone out to 2 pixels. I believe the reason for this is to speed up the painting in the viewport, but if we were to change that out to 16 and just do that section again. So just picking an area where that works nicely. Yeah, so that has then bled out into our margin fine. Similarly, we could clone stamp out this caliper here. If we were to right click, control left click to select the clone area there. Start on the line by left clicking on the texture and just painting across. Just finish that up. So again, you could then take this into Photoshop and continue working on the texture from there. Once you're done with the texture in the viewport and painting out any other bits that are just easier to do in 3D, be sure to go Image, Save As, and save your actual texture. Blender will store this image in memory while you're working on the Blender file. But yes, just be sure to do image, save as, and make it an actual image on your hard drive. Just in case you do a whole bunch of work, close Blender, and then that image is not there when you reopen it. Just a minor thing to flag. So that's pretty much going to do it for this example with the photogrammetry. All of the stuff to do with texture baking and the ray distance and the margins and the bleed will apply to texture baking of any kind. So whether you're baking the normals or the ambient occlusion or baking from a sculpture or a subdivision surface mesh, everything we've just covered with this example will happen with the other types of baking as well. It's just that photogrammetry can often be a good way to show that sort of stuff off. Because of the nature of the surface being somewhat imperfect and lumpy, it's going to create little corner cases and issues here and there, and is a good way to show some of that troubleshooting. Because like I said, when you click bake and everything works the first time, that's great, but a fair bit of this process is the nudging and tweaking and fixing to get from a raw bake or the sort of initial starting point, and working that into being final usable textures for your game. So if we were to leave the photogrammetry example for now and load up Texture Baking Sword 01, we'll cover this more in depth in the practical, but I just want to show using a mesh that's been made cleanly, using subdivision surface modifier, and a little bit of sculpture on the face. This particular face was done in the bonus sculpture video for week 2, if you want to have a look at that and see how that was made. I'll just do a little bit of an example on this sword, and then that will lead into the practical for this week. So again, same sort of process. We can add mesh cylinder because we're matching a cylinder primitive to another cylinder primitive. Whether you do the retopology face by face or whether you match it using primitives as a starting point and then going in and editing from there is up to you. A bit of both is perfectly fine as a way to work. We might want this, 12, that seems good. Scale this down, move this up, go in the edit mode, scale it to match. We can see that this isn't aligned in the x-axis, so doing that initially will cause you less headaches later on. So we can zero that out there. Again, got to make sure the screencast keys is working in this mode. So that's going to have some overlap. It'll be up to sort of your judgment as to how much overlap is too far. This can also be where you start to fix things with the different cage settings and the baking settings for ray distance. So we've got our cylinder, that's about right there. I'll just make a bit of a nudge with the proportional editing tool to bring that in. Set that from connected only to the default. That'll just bring that all in to the side. Because we're not one-for-one matching a exact object, that doesn't particularly matter. But we do want that turned off for this mode. So the difference between high poly and low poly and how accurate that is to pretty much up to your poly count for your particular object. So if you know that working based on your scene and the type of game that it is, that this sword handle has to be 500 polys, you might have the cylinder cover that whole thing and then let that all be taken care of with the normal map, or you might bring that up to there, say this is all fairly uniform. If we extrude that up, bring that in, extrude that up, extrude up again and bring that out, that might be close enough. If this was a hero object, like for example in the Shadow of Mordor games or any sort of third-party game where most of third person game where for the most part the camera is sticking right to the character's back, and you can see the object, like the sword might be sheathed on their back. This particular object might be worth having a few more polys, so we could go in here, E to extrude, S to scale that down, cut in an extra edge loop here. So now we've got the 8 vertices surrounding that. We're going to scale them in. This is all getting a bit difficult to see, so we're going to wireframe. A good friend viewport clipping. 0.01. Change that. Back to item. So now that we've added that little bit of topology, we can get a little bit of a sphere sort of shape, circle even. So again, it'll be a trade-off as to how accurately that matches the actual shape. But that is pretty good. So we E to extrude that out, go back into solid view. These are actually flat in that direction, so we can S for scale, Y to constrain it to the Y-axis, and that would be how I would cut that sort of detail in there. So again, this would extrude up, scale in. Whether you do this in wireframe or shaded mode or a bit of both is up to you. This is often where I would personally do a vertical split and have 2 viewports. Whilst you don't get as much space to look at the model, what you can do here is set 1 to wireframe and 1 to shaded. So anything you do in one viewport will happen in both. But for the purposes of retopology, this might just help you see things a little clearer as you go. There is another option with the viewport shading. So if the object properties, visibility, viewport display, the one underneath it. So object properties, this orange square to the side here, viewport display, and if this is checked in front, what Blender will do is always take the mesh that has in front marked, and regardless of whether I move it behind or in front of the mesh, it will always render on top. This can be useful, but if you see I rotate to the top here, all the faces from lower down are going to occlude anything that's up the top here. So can be handy to toggle on and off just to see how your model's sort of progressing. But yes, just to keep this example going, we'll extrude. Again, up to you as to, and the poly count, how much you go back in and match these shapes. But if we were to bake that, so the whole thing is just 1. And there is a bit of a curve, so we'll cut in another loop and just bring that out a bit to match. So again, we would repeat that if we wanted the circular detail to be in each part. Also, to help things, we might just grab these 4 front faces and scale them in a bit, so it's a bit of a taper. So this will be corrected in the normal map. When we go to bake, those angles will look correct, but just enough to sort of get the silhouette so that when we look at it from side on, there is a bit of change in silhouette, and it'll grab that as part of the texture. So we'll save that for now. Again, we'll do a bit more of that in the prac. If I was to just put a seam along the back here, edge, mark seam, and just quickly add in a seam there and a seam there. mark seam, and this face down the bottom, that one there, is internal. We don't need it because it's never going to be seen, so we delete that. UV editing, select all. Now that's the basic UV map for the cylinder, which we're not using at all anymore because that has the shape is completely changed. So if we were to do UV unwrap with our seams, just for the purposes of keeping this video moving, that is a decent enough UV map for now. Clearly we'd take more time with it once we'd finished the actual mesh, but I'm just wanting to get through as much information in this lecture as we can without making it too long. So to keep things moving, we've got our low poly part of the handle. We would go through and continue the process, whether it's extruding and the traditional sort of modeling tools that we've looked at already, or whether it's using the snapping tools to snap faces. Let's just say this is done for now. We've got our section of the handle that we're going to bake to, back in object mode. Now, with what we're baking from one to the other, there is obviously a whole lot more going on with this model than the previous one we looked at, because there are different material types and a whole range of different individual objects. So what we're going to need to do here is select everything with the border select, and then shift select our low poly mesh, which I haven't named yet. I'll do that now. Low poly handle. Save the file. Again, screencast keys is not on. And we are in our UV editing mode. We've got the same issue. If we tab in with everything selected, it'll show us the UVs for absolutely all of those objects. However, we've got our most recent one selected now as the active object, the low poly handle. So if we add a new material, low poly handle, make this a diffuse. Things like displacement and viewport display we don't need to worry about. So this color here, add an image texture. Now we haven't created our texture for baking just yet. At the moment it's just a blank high poly ref.png. That was from the image last week, which is no longer in the folder, so if we delete that there, we've got the option of either clicking new to make a new image here, or new to make a new image here. If we make one in the slot already, low poly handle, and we'll bake the normals to just show that process. Tangent space normal map, TSNM. Again, naming conventions are up to you, and always keep the same naming conventions within a project. So if you're working as part of a team, check that you're naming your files appropriately. Hit OK. So this hasn't shown up immediately on the side here, but what we can do is select that now that that's an object. A created texture within the scene, sorry. So we've got all of our different high poly objects selected. The active one is the low poly. So if we go to our render properties, it is set to cycles, set to GPU to speed up the process. Sampling, that looks okay because the defaults. Bake, we want to bake the normals, and we want to baking selected to active. And ray distance, we'll just see how this goes first, and then we might need to tweak from there. So while we can do different bakes of the different material types and colors and roughness values, which we will get to in the practical, I just want to once again recap the actual baking part. So we get our progress bar. Now you can see here that this is going through the progress bar multiple times. What this is actually doing is it's taking a bake from each of the little individual objects and then compiling them into one bake at the end here. So we've got a few issues with the normals in particular. But again, issues is what we're here to solve. So this is as much of a troubleshooting video as it is this is the regular process. So at the moment, this sword handle is flat shaded. We will get a cleaner result if we tab into edit mode, select everything, face, shade smooth. That appears to have not, nope, wrong object. So low poly object, select all, face, shade smooth. Now, similarly, while these have a subdivision surface modifier on them underneath, they are not necessarily smoothed either. So we can see if we get in close enough to this leather straps object, face, shade smooth. As a shortcut to keep things moving, if we select all, we should be able to do object shade smooth. Now this will most likely do it to the active object only. If we do object shade smooth, but before we click it, hold down the Alt key. This should apply that smoothing to all of the meshes we have selected. And we can see that that has done it because it's applied some smoothing to that face there. And if we get in close enough, everything should now have smoothing applied. For the sculpted objects, depending on how high your poly count is, you may want that on, you may not. We'll leave it on for now. So select everything, select our handle. We will also notice that while everything in the normals has baked, there is some inverting of colors going along. And while there will be a range of colors in your normal map, you'll get used to spotting the errors pretty quickly. Because most of it should be within that bluey purple kind of a range. So as soon as it hits a transition like this and goes to bright green or bright cyan or, you know, a real bright orange, red sort of thing, these are parts where it's not sure whether it takes the normals from the inside of the mesh or the outside. So this is where we need to play with our ray distance setting again. Handle being a quite small object, don't set it to 0.1 of a meter because suddenly it'll be detecting other parts of the blade. But if we put that to 0.01, so it should look a centimeter out, and check from there, that should give us a cleaner result. So we've got our smoothing, we've checked our ray distance, we've got everything selected. The active object is the bright orange one, so the low poly handle is the most recent one selected. Just save that and click bake again. So we'll get our range of little progress bars. Baking the normals tends to be quicker than most of the other bakes because there's no lighting involved. And we can see here that that is much, much cleaner than what we had before. There's still some errors. So if we tweak this to 0.017, let's say, bake again. This one we can iteratively bake as much as we need to because the baking process is pretty quick. And there we have it. So while there is still a tiny bit of overlap, the options here are to either go into Photoshop and swap that around, or as we can see from the top here, because I've just got the one N-gon, it's not really following the shape that well. That's the high poly one, sorry. This one here. So what we might need to do is extrude that up and merge the vertices at the center. There we go. So again, that would need to be fixed in the UV map. If you've got most of the way through a UV map and you like how it's working, but you do have to tweak something like this, this is where the pin vertices can come very much in handy. So if we've got part of the mesh selected, we don't need all of it selected because most of the UV unwrapping we're leaving. We would select these vertices, right click, pin. Now if we were to do UV unwrap, that has pinned these vertices, so they're not moving at all, they're staying where they are on the texture, and all the other vertices it's unwrapped to match. So for a shape like this, it would, basically fix our problem. And we've now got that extra point up the top. So just to demonstrate the point, no pun intended. Should be just about done, and there we go. So that has now fixed that. That is the correct sort of color. With these leather straps, because there is a lot of overlapping faces real close to each other, what you might need to do is save this as a texture bake that's working, make a second object, second image texture to bake to, only select this one object and only select the low poly, and then adjust separately the ray distance here, so that might be more of a 003 bake. 0.03, go back the other direction. But yeah, basically just tweak this part and bake this one part of the mesh onto the texture separately, get that working better with the various settings, and then you would cut this out and stitch the two textures back together in Photoshop. So I did a little bit of that when we were looking at the arm guard in terms of baking the normals and the ambient occlusion in two parts. That becomes more apparent when you're doing the baking. So if you can get a cleaner result by baking certain parts separately and then assembling it all in Photoshop afterwards. So again, this needed to come out much further than the rest of the mesh did. So yeah, we would take that, select all this blank area, delete it, put the rest of the texture in from the other image file, and away we go. So that's going to do it for today's lecture. We will continue on with this example in the practical, basically just recapping what we've done, what I've shown in the lecture so far, and how that applies to this particular example. Thank you very much.